Hi everyone, welcome back to Learning with Haneen. I recently got a comment asking for an in-depth review on probability. So in this video, I'm going to be talking to you about conditional probability, how to test independence, union and intersection probability. We'll go over some Venn diagrams, and that would be our review for probability. So if you have any questions, make sure to write them down in the comments below. Again, keep watching the January 2024 regents. If you have any questions, put them down in the comments under the videos, and I will be sure to constantly check to make sure I'm answering any of you guys' questions. So with that being said, let's get started. Make sure you like, share, and subscribe. Share with all your friends, and good luck on tomorrow's test. I know you all can do it. Make sure you have your calculators, change your batteries, charge your calculator, have your pen, your pencil, and you guys got this. You've prepared the entire year. And just remember, this is just a test. It does not account for your abilities. It is just a test. And so let's get started. So what we're going to do first is we're going to review the different types of probability. So first, conditional probability. Conditional probability is the likelihood of the second event happening depending on the results of the first event. In other words, it is what is the probability of B happening given that A already happened. And the notation we use is P parentheses B, and we put the horizontal line A. And the formula for conditional probability is the probability of A and B happening divided the probability of A or your condition. So in this case, I'm saying what is the probability that B happens given A. And so I know A is my condition. And so in my equation, A is going to be on the bottom, and the intersection, or the probability that both events happen, is going to be on top. So that is conditional probability. Now, to test independence, something being independent means that the probability of event A happening does not affect the probability that event B happens. So there's two main ways that you can test independence. The first way is through intersection. And by that means is that you're seeing whether the probability of A and B happening equals the probability of A times the probability of B. So that's the first way that you can test it. The next way that you can test it, and I wrote it here in two different ways, is through conditional probability. And seeing whether the conditional probability is equal to the probability of the second event. Not comparing it to your condition. You're comparing the conditional probability to your second event happening. So as I said before, when we were seeing what is the probability that B happens given A, I find that conditional probability, and then to see if the events are independent, I have my conditional probability and I test it with the probability that B happens, the second event happens. So that is testing independence. You can test independence using intersection, or you can test it using conditional probabilities and comparing that to the probability of the second event happening. Then union and intersection. So union is the probability that event A or event B or both events will occur. And you notate that as P, A, and then you put the letter U, B. And again, it's saying what is the probability that event A or event B or both will occur. So when you have mutually inclusive events, those are events that can occur simultaneously, meaning they're events that can happen at the same time. So when you have events that can occur in the same time, they have an intersection. And so your union probability equation would be the probability of A plus the probability of B minus the probability of A and B. So those are for mutually inclusive or events that can happen simultaneously at the same time. If you have mutually exclusive if you have mutually exclusive events, these are events that can't happen at the same time. They can't occur simultaneously. And so your union probability equation would be the probability of A plus the probability of B, because they have no intersection. They have an intersection of 0. So that is union probability. Intersection probability is the probability of events A and B happening simultaneously. And we notate that as probability of A. I'm going to put an upside down U, B, which says what is the probability that event A and B will occur simultaneously. So if you ever want to find intersection probability, you can use, if they're independent events, you're going to multiply A times event B. If they are dependent, you can test it with conditional probability. So you find that by doing the probability of A and B happening equals the probability of A times the conditional probability of B happening given A. You could also use it using the union formula and working backwards. So you have probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So if you're given the union, you're given the probability of both events, then you work backwards and you can find your intersection. So it all depends on what information is given in your question. If you're building on and you have a conditional probability and then they ask you to find the probability of both events, you could use the conditional probability. If you know your events are independent, you know that you can multiply both events and get the intersection. If you're given information on or, you're given the probability of both events, then you can use the union formula and work backwards. So, explaining all of these, and one more thing, I didn't put it on the slides, but when something says a complement, it's the probability of the events not happening. So if I say the probability of, I'm going to write it right here. I'm going to put it in a different color. So complements. And this is noted by A prime or a C. So the complement is the probability that the event does not happen. So if I said the probability that I buy apples is 60%, and I want to say what is the probability of getting bananas, right? So I know that the probability to get apples is 60%. And so if I say what is the probability that I get bananas, in other words, I'm saying what is the probability that I'm not getting apples, which would be 40%. If it had told you what is the probability of not getting apples, you're doing 100 minus 60%, or 1 minus 0.6. And you would notate it as B probability of apple and then put the prime, or C. This would mean that I'm doing 1 minus the 0.6. That is complement. Complement is just the probability that the event does not happen. So, now that we've reviewed the rules and the components of probability, let's practice some questions. So this first question right here says, data for the students enrolled in a local high school are shown in the Venn diagram below. If a student from the high school is selected at random, what is the probability that the student is a sophomore given that the student is enrolled in Algebra 2? So, when we see the word given, keyword for what? Conditional probability. So, we look back into our Venn diagrams going over it. The number right here is the events that, like, here it will be the events of no Algebra 2 and sophomore, or sophomore. So they either are not Algebra 2 students, they're either not sophomores, and yeah. So that's the first part. This part symbolizes students that are in Algebra 2. There's 295 students in Algebra 2. This part right here, I'm going to do it in a different color, represents students that are all sophomores. So that would be 405 students. Let's just double check that. 405 students. This part right here, the 85, represents the probability of having Algebra 2 and being a sophomore. And this is going to be helpful. So, the question is asking the probability that a student is a sophomore given that the student is enrolled in Algebra 2. So how do we write that? Probability of sophomore given that they are enrolled in Algebra 2. So we know that is going to be the probability of sophomore, so I'm just going to shorthand this, and Algebra 2 over the probability of being in Algebra 2. And the total number of students is 1,600. That's our total number of students in the school. Our total number of students is 1,600. And so when I write the different parts, I have the probability that they are a sophomore and an Algebra 2 is 85. 85 over 1,600. The probability that they are in Algebra 2 is 295 over 1,600. People are going to say, well, why is it not 210? Because remember, this right here is the total number of students in Algebra 2. Total, whether they are sophomores or whether they are not sophomores. And it's saying that when we do conditional probability, we're doing the probability of both events happening divided by the probability of the condition happening. So if my condition is being Algebra 2 students, that would be 295 students. And when we simplify that, these cancel out. And so our final answer is probability of sophomore and Algebra 2 equals 85 over 295. Answer choice 2. So that would be the first question. Question number 2 says, which situation best describes conditional probability? So remember, we said conditional probability is the probability of the second event happening given that the first event already happened. So first answer choice says finding the probability of an event occurring 2 or more times. No, not conditional. Finding the probability of an event occurring only once. No, not conditional. Finding the probability of 2 independent events occurring at the same time. Nope, not conditional. 4. Finding the probability of an event occurring given another event has already occurred. Conditional probability. Keyword. Keyword. If you ever get stuck, keyword given. This will hint that it's conditional. Question number 3. Question number 3 says, Sean's team has a baseball game tomorrow. He pitches 50% of the games. There is a 40% chance of rain during the game tomorrow. The probability that it rains, given that Sean pitches, is 40%, it can be concluded that these two events are. So, let's break down our information that we get. So, probability that he pitches 50% of the games. The probability that it rains tomorrow is 40%. The probability that it rains, given that Sean pitches, is 40%. If I look at all of my probabilities, notice our conditional. Probability that it rains, given Sean pitches, is 40%. The probability that it rains is also 40%. So if I remember, if I said that if the conditional probability equals the probability of the second event, what are they? Well, they are independent. Because the probability that it rains is 40%, and because the probability that Sean pitches is also 40%, I know what? I know that they are independent. So that is going to be answer choice 1. So that was questions 1, 2, and 3. And reminder, these are all Regents questions, previous Regents questions. So now for our 4th question. 4th question says, in a group of 40 people, 20 have brown hair, 22 have blue eyes, and 15 have both brown hair and blue eyes. How many people have neither brown hair nor blue eyes? So this is like our Venn diagram question. So I'm going to draw what our Venn diagram should look like. Again, it's not going to be perfect. But we're trying. Can definitely make the square much smaller. Okay, so this is going to be brown hair. This is going to be blue eyes. This we know is both. And this is we know it's neither. And this equals 40 people. So some people might run and go, oh, I'm going to put 22 here, 20 here, 22 here. No. We have to work backwards, kind of. We know that there's 20 people that have brown hair, 22 have blue eyes. And we know that 15 have both. So I put my 15 in the middle. Now, what plus 15 is going to give me 22? 7. What plus 15 is going to get me 20? 5. Now I add this all together. So this equals 5 plus 15 is 20. 20 and 7 is 27. Now, so 27 people have brown hair or blue eyes or both. So I want to find neither. So I'm going to do 27 minus 40 minus 27, and I'm going to get 13 people have neither. So I know my answer choice is going to be number 2. So again, with this Venn diagram, you want to start off with your intersection. We know that our intersection is 15. We know 20 people have brown hair, 22 have blue eyes. If I already know that 15 have both, well, that means I only have 7 that only have blue eyes. If I know that 15 already have both, I know that only 5 have only brown hair. So I know 27 people either have blue eyes, brown hair, or both. To find how many have neither, I'm going to do 40 minus 27, and I'm going to get 13 people. Now, question number 5. It says, on a given school day, the probability that Nick oversleeps is 48%. The probability that he has a pop quiz is 25%. Assuming that these two events are independent, what is the probability that Nick oversleeps and has a pop quiz on the same day? Haneen, why did you emphasize independent? It's important. We know that our question is asking for the probability that he oversleeps and has a pop quiz. So I'm doing what? Intersection. What other information do I get? Both events are what? Independent. So that means that I can multiply the probability that he oversleeps times the probability that he has a pop quiz to get the probability that he oversleeps and has a pop quiz. So I'm going to do 48% times 25%, and I'm going to get 0.12, which equals 12%. Answer choice number 4. So that was question 4. That was question number 5. Question number 6. A suburban high school has a population of 1,376 students. The number of students who participate in sports is 649. The number of students who participate in music is 433. The probability that a student participates in either sports or music is 974 over 1376. What is the probability that a student participates in both sports and music? So, they want an intersection. They give us what? They give us a union. So what am I going to do? I'm going to use my union probability equation backwards. So we know our union equation is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So probability of A or B, so probability of either sports or music, is 974 over 1376 equals probability of A, so probability of sports So this is sports, this is music, and this is both, and this is or. So probability of sports is 649 over 1376, plus probability of music is 433 over 1376, minus and we're going to keep that as x for now. So when we add these two together, we get, do it on our calculator, 649 plus 433. We get 1082 over 1376 minus x, 974 over 1376. We subtract on both sides. And we get negative 108 over 1376 equals negative x. Some people are going to be worried. Oh, it's negative. Remember, this x is negative. So how do we get our x positive? We multiply by negative 1. So finally, the probability of sports and music equals 108 over 1376. And this is your final answer. So we basically use our union equation and we work backwards to find our answer. Now question number 7 says, the probability that Gary and Jane have a child with blue eyes is 0.25. The probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. Given this information, the events blue eyes and blonde hair are dependent, independent, or mutually exclusive. So which things can we eliminate without possibly doing work? Well, choice 3 says mutually exclusive. We know mutually exclusive are events that can't happen at the same time. So if these events cannot happen at the same time, and they say that the probability that they have a child with blue eyes and blonde hair is 0.125, how can they be mutually exclusive? They can't. So we eliminate answer choice 3 and 4. Now, time to test whether they're dependent or independent. We know that to test independence, we can do the probability of blonde and blue eyes equals the probability of blonde hair times probability of blue eyes. We know the probability of blonde and blue eyes is 0.125. Does that equal the probability of blonde hair, which is 0.5, times the probability of blue eyes, which is 0.25? When we multiply them together, we get 0.125 equals 0.125. So we know that our events are independent. Answer choice 2 is our answer. And with that, our questions are done for probability. I thank you for watching these videos. If you have any questions, comment them down below. I will make sure to be checking the channel constantly to make sure that I respond to any of your questions. I will try to probably post short, minute probably solving questions that I can do in a minute for you guys, just to have more review. And yeah, again, if you have any questions, make sure you let me down in the comments down below. Make sure to like, share, and subscribe, and comment down below again. Good luck on your test tomorrow. Remember, it is a morning exam, so be there at your school before the time that they told you to be there. Have your calculator charged or new batteries, pencil, pen, and erasers, and good luck on your test, and thank you for watching today's video. Bye!